Okay, hello everyone. Today I would like to talk about resolving vectors. A vector has a direction and a magnitude. Magnitude is like, its strength, like for example, 10 newtons, because like force is measured in newtons, we should already know this. And then the direction is like the angle, let's say. For example, let's say 50 degrees. So, and now as you can see, we formed like a 90-degree triangle, so we're able to find the component of these two lines. If this was a bit longer, like this looks better. So now, I'm pretty sure we already did this somewhere, or I'm just glitching. However, now I have two components, and first of all, let's talk about, so let's just call this fx, because on a diagram, the y is up, the x is horizontal, so it's like vertical and horizontal, and then the vertical is going to be fy. So the way we calculate what is the like fx is, for x it's cos, and then we put the power, and then the degrees, 50, and the answer of this, 10 cos 50 gives us 6.43, and that will be newtons. Then for fy, it would be 10 sine, again 50, which will be 7.66. Like the arrows, they have to, like go like this. They can't be like this, if it makes sense. They have to be like this, like it was going this way and I was going this way, kind of like, even though remember that they're separate. Now the next example is like the arrow that way. The x will be to the left side and the y will also up as last time. However, it's going to the left, which will cause the x be a negative. Also, the degrees is 20. I forgot to write down. Fx, it will be minus 8 cos 20. Because of the x going to the left, it will be a minus. So the answer will be 7 minus 7.52 newtons, 52. And fy will be 8 sine 20, and that will be 2.74. So the next example question is, find the magnitude and the direction of the resultant forces. We have more than one vector, so let's try to solve it. First of all, let's just quickly do the triangle here. And this is also a way of how you like add it, like where do you start the lines, start to finish. So let's say if it's like this, you start from here, like you start from the point or from the dot, if that makes sense. Also, this time there's another very good example to know, and like in general, as you can see, we formed like a 90-degree triangle, right? And usually the x is cos. However, it's not exactly the x being cos, it's the adjacent being cos, and the opposite being sine. So right now, the adjacent is here, so this part will be x. However, it's not x, it's like the vertical. However, right now, yeah, that's just how it is. So here it is. And the hypotenuse we don't have to worry about, because we just don't have to worry about, because that's, you add it literally by doing this is how you do the hypotenuse, so that's the rule for it. Now continue on the question. We will find the horizontal lines and the vertical lines, so like forces. So for the horizontal, 3 doesn't count because it's a vertical, like it's fully a vertical, so we just don't see it. The 4 Newton one is on the left, so it's -4. Plus the horizontal over here is a positive, and we just put it as 5 sine 30 because of the 5, and 30 degrees. So, and the answer of this all will be 1.5 newtons minus 1.5. And then for the vertical, it will be a 3. Take away the sign because this one's going down. It will be negative 5 cos 30, which will end up into minus 133 newtons. So now it's very helpful to draw like what's actually happening. So let's draw the forces that we see. So the vertical and the horizontal are both minuses, so they go like that. And the force that we're going to be looking for is here, but yeah. So I draw on the forces like on the newtons. However, they're not minuses because when you draw like in the triangle, it's not minus. Like it just becomes because it's like kind of think about it as a measurement. However, they are minuses. You will just have to like formally add them like as a takeaway in your calculator. So to solve this, we just have to use this law. So we will do the height equals 1.3 squared, and we're going to all square root all of it. 1.5 squared, and that equals to 2 newtons.